We now move on to ionic compounds with polyatomic anions. Here's an overview of the naming procedures for inorganic compounds. There are two categories of inorganic compounds, ionic and covalent. In this video, we will continue discussing ionic compounds. Ionic compounds have two components, a metal cation and a nonmetal anion. There are two categories of ionic compounds, those that include monatomic anions and those that include polyatomic anions. In the last video, I discussed the naming procedures for ionic compounds with monatomic anions. In this video, I will discuss ionic compounds with polyatomic anions. Polyatomic anions are anions that contain atoms of two or more different elements. There are three classes of ionic compounds with polyatomic anions, those that are acidic, basic, and those that are neither acidic nor basic. Let's begin with those that are neither acidic nor basic. After naming the cation, identify the anion by its root. Begin by writing the baseline polyatomic anion name, which is the anion root followed by the suffix -ate. The red star shown here denotes that this is our baseline anion. This is where your memorized common polyatomic anion stands. Here is a list of common polyatomic anions. Notice that I've underlined the anion roots and included the baseline chemical formula and charge. The number of oxygens and charges differ depending on the specific polyatomic anion. You must memorize these. Next, see how your chemical compound's anion differs from the baseline. If there is one more oxygen attached to your baseline polyatomic anion, attach the prefix per to your anion's root and keep the suffix -ate. If there is one less oxygen, change the suffix of your baseline polyatomic anion to -ite. If there are two less oxygens, use the prefix hypo and suffix -ite. An example of an ionic compound with a polyatomic anion is Na3PO4. The cation is sodium, so we begin by writing sodium. Next, we look at the polyatomic anion component. This is one of our baseline anions we had to memorize. It is phosphate, so this compound is named sodium phosphate. Here's a harder example, LiNO. The cation is lithium, so we begin by writing lithium. The anion must derive from our baseline polyatomic anion, nitrate, since it contains a nitrogen. Nitrate includes 3 oxygens. NO contains only a single oxygen, 2 less than our baseline. In this case, we name the anion by adding the prefix hypo and suffix -ite to the root nitr. So the anion is hyponitrite. The name of the compound is therefore lithium hyponitrite. I just discussed the procedure for neither acidic nor basic ionic compounds with polyatomic anions. Next, we'll look at the acidic ionic compounds with polyatomic anions. Follow the same procedures as the ionic compounds that are neither acidic nor basic, but swap the suffix -ate with -ic and -ite with -us, and follow it with acid. These acids exist even in the absence of the aqueous phase label, unlike those with the monatomic anion mentioned earlier. Here's an example, H2CO2. The presence of hydrogens at the beginning of the chemical formula indicates that this is an acid. There is no aqueous label, but this does not change its classification as an acid, since ionic compounds with polyatomic anions are acidic even without the aqueous label. The anionic component derives from our baseline polyatomic anion, carbonate, since it contains a carbon. Carbonate contains 3 oxygens. Carbonite contains 2 oxygens, 1 less than our baseline. But since this is an acid form, we replace -ite with -is. This is carbonous acid. Here's a summary of what we have learned so far. Next, I'll talk about basic ionic solutions with polyatomic anions. Most bases that you will learn about in Gen Chem 1 are metal hydroxides. which constitute the third class of ionic compounds with polyatomic anions. Simply name the cation as you did earlier, followed by the word hydroxide. Hydroxide is one of the common polyatomic anions that need to be memorized. It is OH-. For example, let's look into MgOH2. The cation is magnesium, so begin by writing magnesium. And the anion is the hydroxide ion. Plug in the word hydroxide, so this would be named magnesium hydroxide. Here is a summary of all the naming procedures taught in this video. And here is a summary of all the naming procedures for inorganic compounds. In my next video, I will discuss how to name covalent compounds, highlighted here.